This is a demonstration of the Vanguard's Power LiteSava. The LiteSava is a power optimization system designed specifically for lighting systems. The purpose of the LiteSava is to reduce the incoming mains voltage to a setting applied by the user over a range of 50 volts. There are a number of other changes that can be made by the user to the operation of the LiteSava that allow it to be customized for virtually every possible site and lighting conditions. The main purpose, as I've mentioned, of the LiteSava is to control incoming voltage down to the user levels set at the time of installation. You'll see on the display at the moment that we're showing the typical UK mains voltage of about 242 volts. There is no load on the LiteSava at the moment, and so it's just showing a nominal 10 watts, 1 amp going through the system on idle. You'll also notice, which we'll go through in greater depth in a moment, a control panel in the front of the LiteSava, and that is where we make all the various changes and adjustments. The changes and adjustments that we will be able to make is clearly changing the outgoing mains voltage from anywhere between 250 and 195 volts. Changing the time required to reduce down to that voltage. When we select our outgoing voltage, the unit will reduce that voltage over the time that you specify. For example, a maximum of 1000 seconds right down to 1 second. So during that period of time that you have set, the voltage will reduce from the incoming mains to the outgoing voltage that you have set. The other feature of the LiteSava is that it can sense when additional lighting is turned on in a site that's connected to the same circuit the LiteSava is connected to. That measures in 0.1 of an amp, so you can set the sensing of the LiteSava from 1 to 4 amps. So if it detects another load, another set of lights coming on, it will immediately raise the voltage to 220 volts to ensure that the new lighting system has sufficient power to energize, and then it will revert back to reducing the voltage down to the preset outgoing voltage level. You can now see the control panel a little bit more clearer. I'd like to go through some of those features I mentioned earlier on the control panel. At this moment, we are showing on the top line the incoming mains voltage of 242 volts. The unit LiteSava is in bypass mode at the bottom, indicated by this illuminated red LED. The second line of LED readouts is the amperage, and it's less than 0.1 of an amp at the moment. And the third line is a reading of the output wattage. And you'll see, because we don't have any load on it, it's less than 0.01 watt. It's less than 1 watt. On the lower part of the panel here, you'll see one of the buttons I mentioned earlier on. This button is the button for switching on regulation and switching to bypass. The LiteSava has an electronic system automated bypass which will switch over to bypass without any interruption of the lighting system at all. It will just stop the regulation if there is out of range values on the voltage, or if there is some fault somewhere, either inside or outside of the LiteSava. It will go to automated bypass. Here we can manually select regulation on or regulation off and bypass. We see down the lower half here some other buttons. This is the page button. By pressing this button repeatedly, we change the display from power display to protection display to output setting. So we use this button to change the displays to the relevant parts that we will be changing using these three buttons below. This button is the enter button. When you have made your changes to either the power display or to the protection display or to the output settings, by pressing the enter button, the setting is stored in memory. This up arrow button simply changes the values up in each one of the LEDs. And this particular button, the sideway button, changes the display downwards. Just to identify how all of these measurements relate to savings, you'll notice that we have now switched off the LiteSava regulation. We are now on bypass. You can see that the incoming voltage is about 242 average UK voltage, and you'll notice that we're at 8.8 amps and about 2.08 kilowatts. I'm now going to put it onto regulation to show you what the difference is in power. We're now down to 211 volts, down to 7.9 amps, down to 1.64 kilowatts, which gives us a saving of about 22%.